Welcome to 3.4, medians, midsegments, and altitudes. So we're going to start with the definition. What is a midsegment? A midsegment is a part of a triangle that connects the midpoints of the two sides of the triangle. So here we have triangle ACB, and the midsegment is DE. It connects the midpoints. D is the midpoint of AC, E is the midpoint of BC. A couple of properties of the midsegment. If a segment joins the midpoints of two sides of a triangle, then the base is parallel to the midsegment, and the midsegment is half as long as the base, meaning the base is twice as long as the midsegment. So let's see that in use. The question is, what is TU, UB, and QR? Okay, so we know that SR is 40, so TU is just half of SR. So half of 40 is 20. We know that QS is 50, and UB is just half of QS. So half of 50 is 25. And finally, we know that TB is 30, and TB is half of QR. Well, that means that 30 equals half of QR, so we multiply by 2, QR is 60. Okay, so that's a little bit of midsegment. Our next definition is a median. A median is a segment of a triangle whose endpoints are a vertex and the midpoint of the opposite side. So it's a line that bisects one of the sides, and it starts at the vertex. Our next definition is concurrent lines. So it's three or more lines that meet at a point. The point at which they meet is called the point of concurrency. The reason we need to know that is because the point of concurrency of a median is very important. It's called the centroid of the triangle. Think of the direct center of a triangle, and that's what the centroid is. Okay, so here point E is the point of concurrency. It's the centroid of the triangle. The idea of the centroid of a triangle is that it actually breaks it into thirds. Part of the top part of the segment is 2/3, and the small part is 1/3, and the whole thing is 3 times the smallest part, or 3/2 bigger than the bigger part. But the idea is it breaks it into a section of 2/3 and 1/3. Okay, so let's look at this here. XA is from the vertex to the centroid, and XB is the whole median. And we know that the XA is 2/3 of XB. Well, we know that XA is 8. So to get rid of 2/3 XB, to get rid of it, we multiply by 3/2. 3/2 times 8 is 12. Okay, so our median is 12. You could have also just multiplied by 3, then divided by 2. It's the same thing. Our final definition is an altitude. An altitude is the segment from the vertex that is perpendicular to the opposite side. It's also called the height of a triangle. So this is the altitude in an acute triangle. This is the altitude of an obtuse triangle. And the side length of a right triangle is the altitude. So sometimes it's inside, outside, or on the triangle. Property of an altitude. The only property of an altitude is that 3 altitudes meet at an orthocenter. Okay, so orthocenter is the point where the altitudes meet. Okay, so that's literally the whole thing about altitudes, is they meet at what's called an orthocenter. Acute triangle, it's inside. On a right triangle, it is the vertex of the 90-degree angle. And an obtuse triangle, it's outside the triangle. That's it for medians, midsegments, and altitudes. Good luck on the practice.